muds will wash down and start to fill the pore space as well. And so you've got a whole collapse breccia cast system, which, as Mike said, runs down all the way down, and you can see it even down at this depth. So it goes to quite a great depth. And this is exactly the same rock as the cave systems that you can go and visit in Derbyshire today. And we'll look, for those of you who are going on the field trip to Scarborough, we'll look at these en route when we stop in Castleton. It's the same thing. These shales that were deposited on top, deep water, nice and black, bit of sulphur in there. Why do you think they're important? They're a seal for this, but they're also important in another way. Source rock. They're incredibly organic rich. They're actually, I mean, here we're looking at a vertical section, but these, as you go further off into the basins, you get thicker sections of this, which source the hydrocarbons for here as well. So they're a seal to this, which has got hydrocarbon in it, it's just not particularly good quality. And when you look at the porosity and permeability data through here, you can see that, if you look in your handouts, this is the porosity and permeability, well, this is the permeability data, which is more important for getting oil out. Once you get into limestone, you're only around about a millidarcy permeability, very, very low permeability. And even less in some cases, those wouldn't even be reliable numbers. Yeah, and then that gap there is because of the mudstone. Yeah, there's no point in sampling this, you're not going to measure permeability in that. And then what happened after that was that the sediment began to fill sea level effectively, became shallower. You got deposition in shallower and shallower water conditions, and these sandstones were deposited in a fluvial deltaic system, so in a river delta system. Very, very nice, clean, coarse, well sorted, cross-bedded sands from the best reservoirs that you're likely to see. So, and you can see the permeability, Darcy permeability rock, really, really good quality. And a very, very, you know, even however old this well is, it's still got a really strong hydrocarbon stone to it as well. So, not a lot of cement in these rocks at all.
So if you look at the cartoon, there's in your handouts, there's this page that's kind of assigned to Fraser and Gawthorpe, and what Kathy's just been talking about is essentially the top part of this diagram. You know, what we've looked at is the carbonate system, this big carbonate platform that extended over large areas of this part of Britain at the time. And between these platforms were a series of rather deeper water environments and quieter conditions. And that's where thicker amounts of that source rock were formed. And then the demise of these platforms happened when they became emergent. And when they became emergent, they became karstified. And then the water began to gradually rise. The big regional relative sea level rises, tied into tectonics as well, so there's structure going on. And the whole system began to gradually subsided, and the deep water shales extended over the old carbonate platforms. And then from the far north, where there were big mountains, these big river systems came in, big deltas, which gave the sandstones. So that's that story. From a hydrocarbon perspective, potential, you know, these karst systems, if you can get karst systems that have either retained their original porosity, like caves and things like that, or have been leached later, they can be fantastic reservoirs. So we were talking here about if you're in offshore Kazakhstan and onshore Kazakhstan in the North Caspian, some of the biggest carbonate fields in the world outside the Middle East are all predicated on karst surfaces on the tops of carbonate platforms, and you've got the porosity is actually filled with oil, and you get big caves that are literally oil filled. So drilling down into these is a massive challenge because they're overpressured. You go from those kind of black mudstones, which are the source rock, and salt that sits over the top of it, straight into caves, and drilling that is a real challenge, isn't it?
Yes.
It's really, really tough to drill. They lose a lot of wells, but if you can drill into a cave full of oil, gosh, what a fantastic reservoir.
So is that why they always use the overbalance drilling with these type of
they'll tend to do that. Yeah, they're not easy wells to drill. They're very, so Tengiz, Kashagan, Karachaganak are all famous Kazakh fields in the North Caspian.
What would you call this process? Sorry.
Karstification. But karst is a very important process Karstification is a very important process for generating reservoir quality in carbonates. And you find it all over the world, so West Texas, Middle East, and places like that. Okay? This is a fabulous reservoir, fabulous piece of core. Fabulous piece of core. You don't often get this whole section of core, so definitely postcard hand.
I've described a lot of carbonate core and I've never seen a cast like this one. They're not normally preserved. Normally you just get rubble.
Very rarely can you core a cast. They're really difficult.
Here.
Okay.
Okay.
So we've got about 5 minutes.
Hi,
Just
why
to
did
show the quality of the
Yeah, so just come back down the centre.